Welcome to the this video, ma. Uh, so this video is about basics of civil and mechanical engineering, and I'm going to be discussing some points about the unit two, where it is dealing about the casting process, and also it is dealing with the some engines in the part B of this BCMA. So here, what I mean to want to tell you is I have framed it in the question and answers. I have framed it here. You can see this one. So here, if you see what is happening, ma, explain the working of sand casting is taken here. So what is the explanation about this sand casting? So sand casting is generally a term of manufacturing. So this is a term of manufacturing here. So what is happening? The sand casting is a versatile and cost-effective method. So it is a very easy method. It is a versatile, means very important and also cost-effective. So less cost and more effective things can be happening here. The method for producing metal parts of various shapes and sizes. So you can produce different shapes and sizes in this process. This is important of having a four important process are involved. First, you have to make a pattern making, then you have to mold preparation, removing the pattern and core placing and mold assembly. So, what is the pattern making? Is a physical replica should be placed in object in the creation, which is made up of wood or plastic. You can say this. Next, what is the wood preparation? You can also do mold preparation. Sorry, the pattern is placed in molding. In molding 1 minute, I will take a spotlight here so that I can show you the spotlight. Okay, so yeah, thank you. The mold preparation is there here. The pattern is placed in molding and sand. So the pattern should be molded. It should be first. So here you can see this is a casting process. I will explain that one later. And packed to form the moldy cavity. Removing the pattern. While removing the pattern, be careful. It is a very important process in this sand casting. It is carefully removed, leaving behind the shape of the object in the sand. So that shape is printed on the sand that you will be removing. Cores are placed inside the mold to create a hollow portion. So if you want to make a hollow portion, inside cores are placed. Now outside that material flows and it will be a hollow portion. Mold assembly is also the mold halves are aligned and clamped together. So this is a sand casting view you can see here. So this is cutted into two parts. So this upper part is called as a hope and the second part is called as drag. What happens here? I am pouring some molten metal or plastic material or wax which is having a liquidity. This liquid will flow from this part to this process. So here it is called as runner. It is called as runner. It is called as gates. And this gates it is coming to this core part. This core part is there some rectangle part we are going to manufacture here in the in the sand casting. So why it is called sand casting? This yellow color is totally sand. In between we are making the fluid to flow. So now here is a riser. Now what happens? Riser is it this liquid will fully flow and here also some space is there. If this area is blocked, now what happens? This from this area we can pour some molten metal into this to remove the porosities. Means some holes or some gaps, anything is there because this way will be blocked once the liquid becomes solid here. So this is the one. This is the core. Inside the core, you will get a casted thing which you want. So this is here clips are there. This is a clip and this is a clip which is tightly enclosing the scope and drag. So in this process, this casting is made. So next, let us take the next second question of this BCME question. Explain the working of gas welding. So what is the portion we are telling about the gas portion? So gas welding is nothing but it is also known as oxyacetylene. Oxyacetylene involves the use of oxygen and a fuel gas which takes this one. So it is a highly concentrated flame, can melt metals through the torch. So this we are welding process. What we are doing in the welding process is what we are doing that involves the use of oxygen. So compulsory if you want to burn something, oxygen is needed here. You can see this oxygen is there here. We need some oxygens compulsory here. You can see this oxygens are there. So it is a highly concentrated flame. It can be seen through the torch. Torch is a place where it is mixed. The process relies on the combination oxygen and acetylene gas. You can see that this both gases are mixing here. Then only it is what happened is this is mixing. So here you can see, so here what happens 1 minute is going. Okay. So it is the most effective things are used here. You can tell that it is most effective at producing heat to weld steels. So it can flame generates welding gas. Also, it is producing mixing of two gases. What are the two gases? Means here you can see this is oxygen gas and acetylene gases, which results in a flame approximately of 3,500 degrees temperature you are getting. That means you can melt anything, any material of which is having 3,500 degrees temperature material boiling melting point. This flame is used to melt the metal at the seam between the two parts. So this is two parts are melted, two parts melted, and we are going to fill the material in the two parts. Aircraft industries, it is generally used in the aircraft industries. It is also utilized in the cutting steels and process also. Okay. So what is happening here? Pools fuses the pieces form the strong joint. Very strong joint is formed. This gas welding is widely used in the automobiles and aircraft industries, you can see. So generally we need welding. Why we need is where we are using iron parts. So most of the iron parts are used in the automobiles and aircraft sector. So it is utilized even for cutting of the metals also. This process is simple and portable only. So you can take the welding machine anywhere you want. You can carry it. It's portable. So this is the what it is used for. What are the important components and gases? So the standard setup is valued for its portability, low cost compared to electric arc methods. Gases used as is that propane and butane are used. Oxygen equipments is used. The primary fuel is here acetylene is used here. So acetylene gas. Instead of acetylene, you can use propane or butane also for this one welding process. So here I am telling the figure is taken. This is a gas welding sector. This is a workpiece, and this is called as starch. This starch is having two regulators. You can tell or needles. You can tell which is this red color, which is coming. One is oxygen and one is acetylene. So this is here you can see this black color which is there. They have bonded upon oxygen and fuel. Acetylene is used for red color. Anything you can use, but different color should be given for two things. So regulator, what is the pressure of the gases inside the cylinders is checked by using this pressure regulators. So these two gases come and mix here at this portion and generate the heat which is required for the welding of these two processes. Thus, the gas welding is satisfied here. The third question is explain the working of lathe machines. So lathe machines is generally it is a operates as a definition says the lathe machine operates by rotating a workpiece against a stationary cutting tool. So this what is happiness in the workpiece? Workpiece is there which is rotated. Now tool is here. What constant here to shape the materials into desired forms, primarily cylindrical shapes. Working process. The lathe machine functions on the principle of rotating the workpiece while a cutting tool is fed against. The workpiece is held securely between two rigid supports called centers or chinks. So that spindle is having centers. By center tightening that centers, this workpiece is firmly held inside that. As a workpiece rotates, compulsory workpiece has to rotate. Remember this point. Workpiece will rotate and the tool is stationary in the lathe machines. Then only you can remove the material from that workpiece. Otherwise, it is not possible. Time taking process. The cutting tool removes material in the form of chips. So small chips are there, allowing for various operations such as turning, drilling, threading is there. Now, what are the main components? Bed is there, headstock is there, tail is there, carriage is there, feed mechanism. So what is bed is the foundation of the lathe machine. So very good foundation should be given for the lathe. It is a cast iron, very heavy. It cannot be lifted by human beings. Here you can see the lathe machine. So this is the bed which is having a bed. So it is generally lifted upon by cranes only. It is not possible by lifting by human beings. So here see, this is a chunk. This is a spindle where workpiece is going to be held inside, and this tool post is there. This tool post is can be rotated here on this screw thread is there. So this is a tailstock. This is a tailstock, and this is total is a carriage. So some gear systems are provided, and gearbox is there. Some electricity is provided. Now this will rotate. The spindle will rotate. This tool post will come and remove the material from this rotating section. So this tailstock is there for supporting this tool, if any, to hold the tool in some cases. So this is the lathe machine. Here it is having a bed. Bed is a foundational lathe. Headstock is located at the left arm there of the bed. It houses the motor and driving sections. So this is the head. This is the head of this, and this is the tail of this. It is like a human structure only. So this is the head which is having a gear system. In this second one is there. Now tail stock is positioned opposite to headstock. It supports the other end of the workpieces. If any process we have to hold the workpiece from the other side, then this tail post will come here at this post, and this will hold the workpiece from the other side. So what you are having, feed mechanism, carriage is here there. The component moves the cutting tool along the workpiece. So this carriage is nothing but total body, which includes the saddle, crossframe, tool post, everything is there. So feed mechanism controls the movement of the cutting tool relative to the workpieces. This total is called as carriage. This is totally, it is called as carriage. So here you have a tool post. So mainly I will tell you that one portion, this is one, this is two, and this is three. Three portions are there for this lathe machine which are used. So completing that, I will take the next question. Explain the working of laser beam. How does a laser work? So by generally I am showing you this directly. This is a laser beam. How this works is in the figure you can see here. You are having mirrors here. So this two yellow portion, two mirrors are there. They are mirrors, and top is mirror, and this also is a mirror. They are generally ruby crystals. This mirror and this mirror is powered by power supply is given. Power supply. What is happening? These are called as reflecting mirrors. 100% reflection of the light in the center. Now in the center, what is happening? All the lights are coming here at the centers. These are also called as mirrors. They are made up of ruby crystal. Here it is shown in the figure. Also flash lamps, these are shown. Now partially reflecting mirror you can see here. What is happening is this partially reflecting mirror will reflect upwards, but they will go upward. They will touch this reflecting mirror again. They will come down only. After coming down, all the material, um, all the light in this are focused at one point. That is partially reflecting mirror only. So from this mirror, they are coming out of. They are passing through the lens. Now, what the work of the lens is? This is focused one. The lens is making all the lines in a focused line. So this is imported or impinged onto the workpiece where we want the welding portion to be done here. So this will create the heat for the necessary for the welding process. So the metals are welded in this structure. So this is the main working principle of a laser beam. So power supply, capacitor, ruby crystals, lens, welding area, and also this is a laser beam, light beam, partially reflecting mirrors, flash, and 100. So let us go to the theory. In the theory also, this is saying laser works by creating focused beam of the light. So focused beam of light is very important in order to make this stimulated emissions. It involves a exciting process. So what is happening is excitation. The photons with the right energy is excited. What we want to do in the light, we are having electrons, neutrons, and photons, but we want photons to be activated from the atoms. These excited atoms, these excited atoms are photon atoms. Having the same energy, same direction, we are going to create. Then what is happening? Chain reaction. The emitted photons simulate more atoms. More and more photons are coming from the atoms, and they are reflecting towards one direction only. So optical amplification. So the light energy is then amplified through optical amplifications only. So this is amplified means it is double, triple, 10 times, 100 times, and it is focused, increasing. So control the laser beams. System manages the energy and the direction of the beam. So it is direction of the beam. This process allows the lasers to produce a highly precise and instant of the lights to be applied. So it is used. So this is the laser beam already I have told you. Now directly I will completing that question. I'm going to the next question. Explain the working of a 3D machine. What is this 3D machine is, so you can see this one. So first you are having three layers. After that you can see six layers. After that full 2D image is formed. After the 3D image formed. So this is layer by layer it is made. So this layer by layer making of a any object is called as 3D printing. For example, you can see here also. Here also what happens, the rectangle portion is made. First it is a 2D CAD file is made. After that is sent to the cam. After that is 3D printed. After that final crystallization is formed here. So this is a addition process. So you are going to create layer by layer portion, which is a new technique in the 3D printing in the mechanical engineering of the BCMA subject. So now I am going to explain what is this. A 3D printer creates physical 3D three-dimensional object. So three-dimensional object directly we can print by using this 3D forms a digital files using an additive process. So as I am shown here in the diagram, line by line, it is called as additive process from starting from the down portion, it is going up and up on the vertical direction. So this is a additive process typically by melting plastic filament. So you can use input as a plastic or a metal or a resin materials are used, depositing it layer by layer as I said in the diagram. Often it is also called as FDMM, FFF type, uses a nozzle to draw the precious cross-section on the bed, taking them to form a complete solid model. So in this way, this solid model is made. Now what happens is a 3D model is created via CAD software only. So first you have to design in the CAD software. After that, saved as a STL file. Now this slicing software then divides into model into hundreds and thousands. This STL file is divided into hundreds and thousands of thin horizontal layers. It is generating a G-code file which instructs the printer on movement of the temperature and speed. So thus the movement is going to be printed on this 3D movement, 3D motion. So this is the taking of this 3D. This is also the printing process are called extrusion, layer by layer building, cooling and addition. After that it is printed and it is this is extrusion and layer by layer building, cooling and addition. So by completing this, I am going to take the next question. That is explain about the working of a Otto cycle. Now, what is this Otto cycle? Directly, I am going to this here. Otto cycle is completely taken of compression stroke, combustion stroke, and expansion stroke and exhaustion stroke you are having. So, what is happening? The Otto cycle is a foundation of thermodynamic cycle for the spark plug portion. So, though four distinct strokes are taken, that is, one is in stroke, intake, compression, power, and exhaust strokes, which converts the chemical energy into motion. So, it operates on the principle of constant volume heat addition at the top of the sun. So going to this one. So first you can see 1 to 2, 2 to 3, 3 to 4, 4 to 1. So first stage is this one, second stage is this one, third stage is this one, fourth. So first stage as it is saying it is a compression stroke or intake stroke. So 1 to 2 is it is completely both the valves and close. The piston moves up, compressing the mixture adiabatically. Now we are going to be taking the air from the outside. Combustion process. Now 2 to 3 is combustion. The spark plug ignites the mixture. At this point, the petrol and air which are ready to start ignite. This is sent here. Now this constant volume only pressure and temperatures are increases and the main working is developed at this stage. After working is developed, we are having expansion or power stroke. High pressure gases expand adiabatically, pushing the piston down. So now what is the work is produced here we are using for the rotation of this bike wheel. After that it is going to this and completely the pressures and temperature 3 to 4 they are falling down. After 4 to 1 they are exhausted as said in the above this one. So exhaust portion valves and the piston moves up again. This is valves are again moving up in order to take the next charge. Where this is applied is it is usually applied in the automobiles, lawn mowers, other international other combustion engines, internal combustion engines. The internal combustions here. Completing the diagram, I am going to take the seventh question, which is explain the working of diesel engines. A diesel engine, what is happening directly? I will go to this one. I will explain you. So here you can see one constant pressure. So pressure is taken on the y-axis and volume is taken on the x-axis. So before that we had only one volume process. Here you are having a one pressure process and one volume process is there. So both process, this 1 to 2 and 3 to 4 is one is compression, one is expansion, both are same, but the heat addition and heat rejection, they are 2 to 3 and 4 to 1 is different in this one when compared to Otto cycle. As per going to the definition, the diesel cycle is an internal combustion engine process characteristic by the constant pressure heat addition. So heat addition is done at the constant pressure process. The four main steps in this one are isentropic compression 1 to 2 process, and constant pressure combustion 2 to 3 process, isentropic expansion 3 to 4, and constant volume heat rejection 4 to 1. The fuel ignites via high compression temperature rather than a spark. So here we don't use any spark. So due to high compression side, it will ignite. So you can see 1 to 2 isentropic compression. Air in the cylinder is compressed isentropically, raising the pressure and temperature significantly. Volume is decreased. So very high isentropic compression is nothing but this is a compression process. Now heat addition. Here we don't use spark plug, but fuel is injected now. So first process only air is taken. Now fuel is injected. Now fuel and air both burns and they allow all the lots of energy which is useful for the rotation of the wheels. Then what happens is the piston moves outwards or downwards in this section 2 to 3. 3 to 4 is expansion. What is expansion is the high pressure combustion is done now. After that, definitely the pressures and temperatures slow down in the process, which is the piston is moving on to downwards. So the constant volume heat rejection. Now this is a constant volume where the valve opens and the heat is rejected at the constant volume. This is a isochoric process as the pressure develops. So this is the 1 to 2 process, is a 2 to 3 process heat addition process, and 3 to 4 expansion process, 4 to 1 is exhaustive process. So this is a very important process in this one. So completing that, I am taking the next question, that is explain the working of refrigeration. What is refrigeration? Refrigeration works by using the closed loop systems with closed loops with a refrigeration fluid to extract the heat from the enclosed thing. So a room is there. In the room we are having a heat. We are continuously removing that heat from that room. Now already that room will become cool. This is the main basic principle behind this one. So it is an insulated space. Now we are closing all the windows and doors so that that will not go outside, or outside heat will not come inside. So release it outside, cooling the interior. This cycle involves four steps: so compression, condensation, expansion, evaporation. In the room, from the outside, air is compressed and it is taken, and compressed air is taken, and after that, air is passed through the condensation process. Condensation process is nothing but it is mm, this refrigeration process. Here you can see my condensation is the hot gases flow through the coil. So hot gas is flowing through the coils, now releasing heat into the surrounding area, turning it into a high pressure liquid. Here the compression is the cycle starts here low pressure only. So low pressure the cycle starts. Cool refrigerant gas is compressed into high pressure gas. So here you can see this is a evaporator is there. The cold air is coming here. The cold is air coming here from the outside. A fan is also provided here. So it is the evaporator. In this where you are going to keep this refrigeration system of the refrigeration system is where the items are kept here. In these items are kept here, the heat is continuously taken and it is sent to this here, and then it is cooled here condenser, that is the heat is passed outside. And now that again the condenser whatever is there, it will cooling process, again that liquid is sent to this expansion wall. In the expansion wall, what is happening, again expansion of that liquid is done. Again the liquid plus vapor which is entering into this evaporator, now again carrying this heat from this portion and is sending to the next stage. So it is nothing but removing of the heat. Removing of the heat is called as this one. So here driven by a compressor is very important to move heat from the low temperature area to a high temperature area. So this will become low. That is what happening? This heat is taken from this evaporator, sent to condenser. Condenser will send that outside, that heat. So continuously removing air from this evaporator, it is becoming cool. No heat means it is cool. If heat is there, it is not cool. This is the basic principle of this refrigeration system. So here, if I read this one, these four devices are connected in a circuit only. Compressor is just cool refrigerant gas is compressed. So outside coming gas is compressed here for the use of compressor. Condenser is the hot gases flow through the coils. The hot gases which are there, they will coming into this coils, usually on the back or bottom, releasing into heat the surrounding area. So expansion valve. This is the expansion valve. The liquid passes through a restriction capillary which lowers its pressure. So down lowers the pressures here before entering into this one. Till here you are a high pressures, here coming low pressures. It will enter evaporation. The cold liquid through the evaporator coil inside the fridge absorbing heat from food items. So from this, whatever the heat is there, we are absorbing. We are using NH3. NH3 ammonia is as a refrigerator. That refrigerator will remove absorb the heat from here and it will go out, it will raise the condenser again, that will come refrigerator, it will take the heat and go away. So it will continuously doing this one. So this is the working of this one. So taking the next question, the ninth question, explain the working of electric vehicles, electric vehicles. You can see this electric cars operate here by using electrical energy stored in a high voltage battery packs to power an electric motor. So one electric motor is there that is powered back. The wheels instead of using an internal combustion engine. So you are going to remove the internal combustion engine. You are going to plug this battery instead of a high voltage battery packs, which will do the work of a engine. Okay, here you can look up to this diagram, you will understand what I wanted to say you. Here battery is there, controller is there, motor is there. So a controller is controlling the battery and also it is controlling the motor. So this is an external charge you can do for this controller. Okay, this is a regenerative thing is there here. This is a block diagram of electrical vehicle. Here, what happens? It is definitely a working principle. If you are taking what is happening here, you are having some key components here. Having what are the key components? Is battery pack, which is storing the electricity, and this is made up of lithium ion to power the coils. Other things are not possible. Only this is done here for the use here. So electric motor is used which converts this electrical energy to battery into mechanical energy. So this is the electric motor which is converting this energy from the battery into mechanical energy. This mechanical engine drives this back wheel. So that is kept in the back wheel. So now controller and inverter manages the flow of energy between the battery and the motor. So this battery and motor, they are controlling both the things. Charging system is just your onboard converters AC electricity is applied into DC only. So alternating current is from the outside taking converter into DC recharge the battery. So this is a regenerative braking system is also there. During deacceleration in the electric power, the motor acts as a generator, converting the kinetic energy back into the. So while braking also electric battery is charged in this electricity. That is a big advantage in the electrical vehicles. So 10th question I am taking the last question. So working of a hybrid vehicles, what is the working of a hybrid vehicles is hybrid vehicles work by combining a conventional internal combustion engines, petrol or diesel. So this is based upon both a electric vehicle and a petrol engine is together with one or more electric motors. So one motor can be there, two motors can be there, one battery can be there, two batteries can be there. Dual power systems allows the vehicle to switch between sources. Two are combined, but it is costly because two engines are existed. One is battery is existed and also petrol or diesel engine. Any one you can keep here them together to maximize the fuel efficiency and the performance. Okay, here you can see this one here one. So here you can see this one. Here gearbox is there for this driving wheels. This gearbox is connected to electric motor and power converter and generator and battery. So this is electrical vehicle. Here you can take fuel tank is there and internal combustion engine, whether it is a petrol or diesel is connected. This is connected to one wheel, this is connected to one wheel. So if you want to switch this one, you can run with fuel a fuel on the internal energy, or you can switch to battery energy. Two sources are available, source one and source two. Anything is possible from the this hybrid vehicle. So that is what he is telling. This is internal combustion engine and the acceleration both are used here. So here it is consisting of a power control unit, a low speed coursing, full acceleration is there, regenerative braking is there. Regenerative braking means while you are braking also the electricity is generated here. Here a central power unit acts as a brain deciding thousands times per second. So control power control unit you can see here. This is control power unit which is a power converter is there which is controlling this generator and electric motor. It is a connector between these two. This is the brain of the diagram. Low speed city driving. The electric motors usually powers the car alone only. So here zero emissions are there. Very very important point. Zero emissions are there, and also here, highways, the internal combustion engine takes the lead as it is most efficient as a steady high speeds. If you want to go for high speeds on the highways, then you can switch off to this petrol engine and you can go off full acceleration. Both the engine and the electric motors together to provide maximum torque. At same time, to both engines you can use for give more torque for the your engine. So this is the end of this unit two of this portion. So I think you would have get the information what you wanted or what you want search in the BCME program. So if any comments are there, please leave the comments or any doubts is there, you can write this doubts here. So I will be replying for the your doubts also. So any suggestions also please give me. I will be choosing and I will be correcting those one. Thank you. Thank you. I am signing off.